HOD sir, shall we start?
Yes, Prasanna. You can introduce.
Yeah. So, dear participants, very good afternoon. So, we welcome back for the day two afternoon session of AICT sponsored FTP series organized by our department CSC of Mahindra Engineering College. On behalf of my department and my college, I would like to place on record our sincere thanks to AICT for granting the fund to conduct this faculty development program in a grand successful way. And of course, it's pleasure and privilege to welcome you all again for the afternoon session. And of course, I cordially welcome our resource people for the afternoon session, Dr.ANBUNAThan sir, for being the founder and CEO of DigiTrans Solution, Bangalore. We welcome you, sir. So Dr. Anbunathan sir has planned to deliver his lecture on the title as Introduction to Blockchain, Smart Contracts and IoT. So let me take the opportunity to brief about its profile. Sir is having many professional experience, being the result-driven professional with 23 years of experience in the area of embedded software development, testing, test automation, and delivery management. Sir is having the provision in building AI-based deep learning models to provide business solutions. He is having that expertise in hands-on in digital transformation technologies such as AI, ML, and DL, and so on. He is proficient in embedded system designs. Also, he is proficient in handling various product development and firmware programs in compliance to quality standards. So he is having this excellency in quality and project management, ensuring in meeting organization business objectives through various quality initiatives like Six Sigma, Green Belt, and Black Belt projects. Being an appraisal team member for CMMI level 3 and level 5. His expertise in embedded development, testing tools of mobile 2G, 3G, LTE technologies, and so on. So being a researcher in the field of AI-based source code generation and software test automation and so on. Sarah has published 7 conference papers and 8 journal papers in the field of software test automation. He is expertise in applying genetic algorithm in automation frameworks. So Sarah is having many professional experience. He has started his career as design engineer in a company from Madurai, and right now being the founder and CEO for the company DigiTrans Solution, Bangalore. Cyrus started his career, that is education career, with the diploma in EEE, followed with us, he has completed AMI, MS, and by 2018, Cyrus completed PhD from Bardhan University. So Cyrus is having many professional membership also, being the associate member of Institution of Engineers, Calcutta. He has been elected as honorary secretary for CSI Bangalore chapter, and Cyrus elected as vice chairman for CSI Bangalore chapter, and he has been elected as chairman for CSI Bangalore chapter during the period 19 to 20. So Cyrus is also having the membership in IEEE and ACM. I thank all my FDP team led by our HOD sir, Dr. Kannan sir, for giving this opportunity to deliver this welcome address. Let me hand over the call to our resource people, Dr. Anbunathan sir. We welcome you. Thank you.
Thank you, sir. So, good afternoon, everyone. Let me thank management of Mahindra Engineering College and Dr. Kannan and Dr. Balakrishnan, Dr. Vijayarajeshwari, Dr. Krishna. I don't know many people. Sorry for that. In future, we will come to know very close. So we'll start with blockchain and IoT. So the outline is, we'll see what is the foundation of blockchain technology. Then how blockchain works. That we'll try to understand. Then private, public, and consortium blockchains. Smart contract. What do you mean by smart contract? How you can create your smart contract? And Ethereum foundations. Then cryptography. Then double spend problem, mining in Ethereum. Then IoT will see what and all the main aspects of IoT. Mainly, this session is we are trying to build one blockchain application. So, which is a IoT application basically. IoT application works on blockchain and then Raspberry Pi. So it's supposed to be a hands-on session. Unfortunately, because of online and many people are using mobile phone for these sessions, we could not do the hands-on. But anyway, I have published all the steps in the medium.com. I will show the link. So what your people can do is today evening you can try from medium.com. You can the steps you can take, and then you can try to execute. Then tomorrow morning again when we meet, you can ask some questions. So if you have any doubts, so that you will understand 100 percentage this session and the next subsequent session. So both are more practical oriented. So let me introduce about our company. So we are digital transformation based company. Digital transformation makes many changes in our daily life. It brings changes in leadership, innovative thinking, new product ideas, and new business models. Digital transformation involves modern technologies such as artificial intelligence, then blockchain, IoT, then cloud, big data, analytics, then data science, then Web 4.0, mobility, 5G, and social media, 3D printing, autonomous vehicles. Digital solutions provide development support for new products based on digital transformation technology. This is our website. You can visit our website. So these are all the main products what we already delivered to the market. One is virtual test engineer. This is AI-based test bot. So it takes two inputs. One is UML and another one is UML state diagram basically. Then menu tree database. Then it generates test cases, test scripts, test APKs. Then test execution also it does automatically and then generates the test results. So one test engineer what and all will do. So it replaces all the human activities and it does everything intelligently. So you can see the more details in the website, the page 145. Then AI-powered intelligent document finder. So intelligent document finder is useful in our computer. Suppose if you want to search some document in the computer, semantically you can search, for example, PDF, Word, Excel, PPT, and all. Semantic means what is the meaning? See, for example, White House, if you search, it will display Rashtrapati Bhavan also because both are semantically same meaning. So it will display so the same way. Suppose one doctor wants to check semantically similar persons. Even though the keyword is not matching, but semantically same. That way you can find the documents or case histories. So you can find this in the page 122. You can download also. An AI-powered recommendation system. For example, if you search in Amazon website, then it will suppose one saree if you search, it will throw another 100 sarees. So recommending based on the previous customer who bought. So along with this product, what and all other product based on that old customer database, it is creating some new customer recommendations based on artificial intelligence. So these are all three products. Then we are working on testpod 2.0 also, so which is the advanced version of testpod 1.0. Some of the prototypes what is available. One is smart home solution. So this prototype is useful in the smart home product. So smart home product is still going on. So AI powered voice command. So let me execute this one once it is downloaded. So here what it is doing, it takes the voice command and then it is trying to switch on and switch off the device like fan and all. Then it uses AI, data science, IoT, Android, and cloud computing technologies. So also this is available in the Medium article. If you go to the Medium article, you can download the steps involved in this. You can try. Actually, you can use in your home. Let me run this. So using voice command, you can control your lights and fans anywhere in the world. So that is the advantage. It runs on IoT. So this is also IoT device only. Here also AI we are using and data science we are using. So what we are doing here is suppose using gesture control. The gesture we are trying to control our door. See, we are using two gestures. One is palm and fist. So here you can see when our palm is shown, the door is opened, and when our fist is shown, the door is closed. So this also you can use wherever in the world, it doesn't matter. You can close and open your door anywhere in the world. Suppose if you have doubt after coming to the office, see whether my door is closed or not, just show the gesture, then it will close the door. So it will remove the whatever doubts or whatever the some bothering is that will remove actually. So it involves AI, data science, IoT, Android, and cloud computing technologies. So the Medium article is released here also. So you can open the Medium article. You can try. So if you try only, you will come to know. You will learn these technologies fully. So this is the topic of the day. You can see here. This is what we are going to design. This application we are going to design today and tomorrow. So this is a part of the smart home solution. So here we are using blockchain, IoT, Web 3.0, and cloud computing. So you can see this screen. This is Raspberry Pi is running here. So blockchain is running here. So this is two miners are running in Google Cloud platform. This is Raspberry Pi. This is the light we are going to control. See, it is switching on when a transaction happens. When we deposit 10 tokens, you can see here, we are depositing 10 tokens here. That time the light is switched on. So when we withdraw 10 tokens, that time the light will be switched off. See, this is switched off. Now we withdrawn 10 tokens. You can see here, we have withdrawn 10 tokens here. Now again, we are depositing 10 tokens. So whenever the transaction happens, the miners will mine the ore and then it will give the approval. Once it approves, the light will be switched on and one block will be added in the blockchain. See, now light is on, one block is added in the blockchain. Now we are going to withdraw the token. See, within 3 seconds it switched off. So it depends on miner how fast it is resolving the problem and then how fast it is approving. The proof of authority we are using. So this is what we are going to design today, tomorrow. So you have to boot up yourself, lot of information will be poured. So you have to accept all the information and you have to take into that. Evening you try in your home, you have to spend some time, considerable time, so that tomorrow you can ask some questions. So this also published in the Medium article. So maybe I will post this Medium article link in the chat box so that you can work in the evening. Evening you do the work and then come back tomorrow with the questions. I'm expecting at least 10 questions. 44 people are there. At least 10 questions I'm expecting. So this is my Medium article. So here, what and all technology is involved? So here blockchain, IoT and Web 4 3.0 cloud computing are involved. So what is the next step here? Any idea? So now next step is adding AI, then adding Android, then adding big data analytics, then we have to add social media, then we have to add 3D print. So this is the next agenda. So if somebody interested, I already started with AI and Android. Somebody interested, you join with me. So we'll make one more mini project, so uh, which will involve this technology. So apart from these 4 technology, we'll add more technology and we'll make it more strong. So I will send my uh, WhatsApp number also. You can post me, if you are interested, you post me a message in the WhatsApp so that we'll form a team. Yes, sir. Monotos. Yes, sir. Thank you, sir. We will test after receive from Amazon. After receive from Amazon. Okay, you ordered the ARPI, I think. So, okay, sir. Okay, sir. No problem. Okay, then uh, we will move to next one. So, I will take it through each and every step. I will design this application. So, we will see the theory, the background theory also we will see thoroughly. We'll understand the theory, then we'll understand the each and every steps, and then we'll try to design this application. At the end of the session, this application you can do yourself. So do it yourself. Apart from this, this is one robo. You can see here this robo is moving from one place to another place using reinforcement learning, deep learning, then obstacle detection, then MQTT protocol like IoT. This is IoT device only again. Then Raspberry Pi. Here, what and all we are using? We are using Raspberry Pi, Arduino, ESP8266, MPU6050. These many VLSI chips are used to make this robot to move from one place to another place. So here, one advantage is Wi-Fi sensors are used for real-time location service. That is RTLS. So that is very cheap, very cheap and best RTLS. So this is indoor location actually. So outdoor we can do with GPS, whereas indoor we can do with Wi-Fi sensors. So this is for a test bot. So here what we are doing is, so we are using AI, data science, Android, APM, and cloud computing. These many technologies to test the camera application. So this also released in the Medium article. So just go through that. Each and every steps are given here. So you can test using. So the camera application is very tough to test usually because the no automation tool is supporting. But in this case, we are using AI to identify or they recognize the menu icons of camera application, and then we are clicking different. See here, we are clicking different menu icons here. So then using AI data science, we are checking using APM also. We are we are clicking on different icons. So that is the one. Then it will come as testbot 2.0. So the research is done. Research is ready. Now we'll make the product and then deliver as testbot 2.0. So it recognizes all the menus and then it clicks. So apart from this training, we are giving many trainings like machine learning, deep learning, reinforcement learning, blockchain, Internet of Things, Hadoop, Spark, data science, Android 4.0, cloud computing, robotics. So it's a 72 hours training. So if you go through this training, you will understand complete digital transformation. You will be able to make many such innovative products, and which you can use for your smart home, or it can be used in the different industry also. So you can plan this 72 hours training whenever you feel like. So let us enter into the blockchain. Before that, I want to show the Medium article of what we are going to design. So this is the application we are going to design. So just 1 hour before I launch this, I release this article. So maybe see here, this is the architecture. So here what we are doing is, here one virtual machine we are creating in the Google Cloud platform. Another virtual machine we created in the Google Cloud. Another virtual machine. So two virtual machines are there. So one virtual machine works as a miner one, and another virtual machine is working as miner two. So it mines the blockchain. It adds new blocks, and it approves all the transactions whenever miner one is sending to RPi, Raspberry Pi. These miners will do the mining work, and then it will approve the transactions. So here you can see there is a relay connected to the Raspberry Pi, and then the relay is another end of relay is connected to a light which is switched on and switched. Already we saw the demo. So you can see the steps involved here. See here we have two virtual machines running for miners, and then Raspberry Pi for one more node, which is which is involving JavaScript, and then Truffle environment to build a smart contract. That is Solidity program we are going to make, and then we are going to compile using Truffle, and then we are going to deploy using Truffle, and then we are going to use this for controlling the light. So control the light from miner one through RPi. So these are all the 4 steps. So here you can see this is a Google Cloud platform. We have made two virtual machines. So this external IP of this is 35 247 4760, where 34 105 65 4 second second VM. So here what is the prerequisite? So they launch at least two virtual machines, then install these two virtual machines. Then you have to install this Geth version. So Geth has to be, Ethereum has to be installed. So I'll take you through all the steps. So you can also try today evening. Then the creating Genesis block. Then I'll explain what is Genesis block, and the miner how to do how to run the miner, and then you can see here how accounts are created for each miner, and each from one account to another account, how to transact the uh, tokens or ether we can transfer. So we are trying to build one private blockchain where we are running the blockchain, and then we are trying to do control our devices using blockchain. So the here you see the miner one is started here. So this is the command used for running the miner one. I will come back. I will explain this later. So I am just going through the one glance. So what we are going to see these two sessions. Just I'm going to just I'm showing a glance at a glance. I'm going to show all these steps. So then so miner two we are starting. Then we are attaching the windows with this, and then see using the attachment we are starting the miner, stopping the miner. Then the ethers we can send from one miner to another miner, then the miner 2 to miner 1, then miner 1 to Raspberry Pi, from Raspberry Pi to miner 2, Like that, so different transaction will try first. Then if everything is working fine, then the next step is, so this is a pairing of miners. So the miners are paired. For example, miner 1 and miner 2 and Raspberry Pi are paired together. All three nodes are paired. In this case, initially we will pair miner 1 and 2. Then later we will add Raspberry Pi also. See here you can see GCP firewall settings so that the miner 1 can transact with miner 2. So then these two enode address will add in the static nodes.jsr so that these miners will automatically pair instead of manually pairing. Whenever we start the miner, it will automatically pair each other. And admin.pairs will give the pairing information like these two are paired. Then we can send the ethers from one node to another node. You can see here account 1 we are sending, then miner 2 balance we are taking. Then we are sending the transaction. 10 ethers we are sending here. You can see here. Then miner 2 again the send 2 ethers from the miner 2 to miner 1. Then now we are synchronizing the Raspberry Pi also. So once Raspberry Pi is synced, then see here, three nodes are synced now. Miner 1, miner 2, and miner 3, all addresses. See, miner 1 is running on the uh, address, the whatever IP address of miner 1, VM1, the IP address of VM2. Then this is the IP address of Raspberry Pi. You can see here now the uh, we are seeing the peers. The admin.peers will give at least three miners are paired. So send ethers again from miner 1 to Raspberry Pi. Then send ethers from R Pi to miner 2. Like that, we have to check once the pairing is done. We have to check whether transactions are happening between miner 1 and miner 2. This is a Raspberry Pi configuration. So Raspberry Pi, you have to install, see, the initial setup required one Raspberry Pi, one SD card, one LAN cable, one keyboard, a display. Then prepare Ubuntu SD card, then set up Wi-Fi, then install Ethereum. So once Ethereum is installed, synchronize Raspberry Pi with the private blockchain. Then set up the Raspberry Pi node. Once node is ready, so we can configure some accounts. Then so here the Raspberry Pi node is the blockchain is started here. So this command will start the blockchain. And now attach one more window to control this blockchain. Like you can get the address like admin.nodeinfo enode. So you can get the enode address. Then permission you can give. The next one is now truffle we are going to use to make the smart token kind of smart contract. Now, what do you mean by smart contract? It's a program which runs on blockchain and it enables that transaction between the nodes. So it's a peer-to-peer network basically. So one peer to another peer, it will send the transaction. So truffle will once you deploy it, so the truffle console you can see the smart token address, then
Sir, Anbunathan sir. Link got disconnected seems.
Sir, network issue நினைக்கிறேன் sir.
Hello, am I audible?
Sir, now you are audible, sir.
Yeah, yes, sir. Yes, madam.
But in
Sir,
meantime, we
network
couldn't
got
get
down
your side.
actually, momentarily. So that is the reason. But again, it came back.
Okay, sir.
Sorry, I will continue now.
Please,
So
sir.
here, yeah, I will present now. 1 minute, just a minute. So we are here. Sorry for the interrupt. So here you can see the truffle. Truffle is used here. Truffle console, you can see here the smart token address and then ABI. What is ABI? Application binary interface. So where it will give the interface for your application and then with the smart contract. So any application can communicate with the blockchain using this ABI. So then we'll create and deploy the smart contract. So install Truffle, then open a new window with admin, make directory, then all these Linux commands, then install Solidity. These two lines are very important. I lost 2 minutes, 1 week I lost because of these two lines. So here you have to install this version 4.1.116 and Solidity you have to install 0.4.15. These two lines are very critical. So if you don't follow, again you have to waste a lot of time. So take care of this. Then Truffle init, Truffle compile. So here, this is the Solidity program, that is smart contract. So this smart contract has the name of the smart contract is smart token. So here you see, so I will explain the smart contract when the slide comes to that page. Anyway, just one overview I'll give. So this smart contract, what it is doing, it has two functions like deposit token and withdraw token. You can see here withdraw token also. So these two functions really make the transaction from miner 1 to Raspberry Pi. Whenever you deposit 10 tokens, then Raspberry Pi will get the 10 token. If the number of tokens in Raspberry Pi is greater than 1, that means it is 10 now. So it will switch on the light when the Raspberry Pi withdraw this. So now miner 1 withdrawing 10 tokens from the RPi. Now RPi token, number of tokens in RPi is 0. The moment RPi is having 0 token, then it will switch off the light. This is the logic we are going to build. And the smart contract is nothing but the logic of your application. So you have to deploy this smart contract so that a blockchain, any nodes in the blockchain can communicate with each other using this smart contract or nothing but logic. Using this logic, any peer-to-peer nodes can communicate with each other. So now you are deploying how you are going to deploy using the deploy contract using this function. You are going to deploy your token name is your smart contract name is smart token, which is Solidity program. So then you are going to deploy this. This deployer.deploy means it will deploy this smart contract. Now Truffle will understand this, and then you can see here in the localhost port 8042, it exposes this smart contract. Now see here miners, you have to start now. Both the miners should run. So then compile and deploy your contract. Now you compile the smart contract. Then you have to use Truffle console. You have to migrate. See, this Truffle migrate will migrate the smart contract. Once it is migrated, that means it is now it is available in the blockchain. So the Madam, one person called Karthik is waiting for entering the session. Please allow him.
Allowed, sir. Allowed.
Yes.
Okay, sir.
Then truffle console. So in the truffle console, you can get the smart token dot address means whatever smart contract you have the address you can get obtain here, and then you will get the JSON stringify smart token dot ABI means application binary interface. So this is the binary interface you will get. So this ABI with this address, any nodes in the blockchain can communicate with each other using this logic. So now you can test this smart contract using the Coinbase, the using this address. You can using this ABI. Then you are building Web 3.0 based contract this with this ABI. Now my contract instance is created. With this instance, with this address, I'm going to deposit the token. You can see here, I'm depositing 10 tokens. So whenever 10 tokens are deposited to the RPI's Coinbase, that means RPI's main account, I'm transferring the token from the miner one. So I'm depositing 10 token from miner one to the RPI using this deposit token. Then I can get token means I can get the how many tokens are available in the in the Raspberry Pi. Then withdraw token from miner one. I can withdraw 10 token from Raspberry Pi. Now Raspberry Pi is having 0, so it will switch off the light. This is the logic. So this is the project setup. You need Raspberry Pi, you need small light and a relay to connect with. So I am connecting to 17 port 17 to 17 of the Raspberry Pi. Then control RPi port and light. Start miners again. So miners should be running. Then prepare RPi. You can see here RPi preparation. Once RPi is prepared, now you see we are going to write a program which will read this token and then it will switch on and switch off the. So you need Web 3.0. So here you have to configure the Python. Then you can see here on off is the module npm module which is available, which is used for switching on and switching off the IoT device. See here now I'm creating a folder. So here we are going to create a JavaScript function which will read this token and then it will try to switch on and switch off the lights. You can see here here we need on off module, GPIO control for GPIO control, then Web 3.0 we need. Then you can see here this is the port I'm going to read the token information. You can see the contract address, same what we got from the truffle, same address. Then ABI, whatever we got from truffle console. Then we are creating a contract again. So now I am switching on here. So now I am going to define a button. So these lines are not used by me. So it's not used actually. But anyways, this function we are using, so status. So then you can see here, actually what we are doing here. So when contract on value changed, then you can see always the source status is error will throw if some error is there. The what it is doing source status function. You can see the token value it is obtained in this statement. So now I know how many tokens are there. If token value is greater than 1, what I'm going to do is I'm going to switch on the LED, or if token value less than 0, I'm switching off the LED. So this is the way I'm controlling the LEDs. So then one more information is that I'll tell now. So now the run the client application. So this has to, you have to run with the node.js, node smart token.js. This will run the application. The application will keep on listening to the token change. So whenever token is getting changed, the application is going to react based on this. So test your application using instead of mist, we are directly using the whatever no the command line. So here you can see here. So we are creating the smart con again. So here one variable we are creating ABI, then again web 3.0, again we are address we are using now. So in the from the command line, in the minor one attachment, from the minor one attachment, we are sending a deposit token, 10 we are sending. Then here you see the get token. So how much it should display 10 now. Then observe at this point of time, you got to observe the Raspberry Pi port should be high. That means the light is on, and you can see again withdraw token 10 I am sending. This time observe Raspberry Pi port low. So the demo is, as I showed you, this is a demo is added, and this is a very important information. All the source code are available in the GitHub, so you can take the source code from there. Anyway, all source code I have added in this Medium article also. So you can take latest code from the GitHub also. Then these are all the references. So this is the work very close with our work. So based on this only I built this. So you can go through this all 6 part so to understand. Then how to execute smart contract, Ethereum smart contract. Then Edureka, this is also very good. Then this is the GPIO introduction, like Node.js, how we can use for GPIO control of Raspberry Pi. Some sample code is available in this link. You can click on that. Then this is my contact. You can see here. This is my contact. So this Medium article is the Bible for your today and tomorrow session. So you can try this. If you have any doubt, you can ask me tomorrow, or you can send WhatsApp message, or you can send mail. I will react. I will send the response to your message. So now, how we did this? So this is what we have done. This is what we are going to design. So today and tomorrow. Now, the question is how we have done this. These sessions will answer the question how we done this. So let us start the slide now. So what blockchain exploration and investment happened? So 2016-17, there was a early adoption, like the blockchain was. So there is leading edge banks see the value of blockchain and begin deployments for asset classes that are bilaterally traded and have no central clearing authority. Now, regulatory certainty drives adoption for external users. Then regulatory authorities realize the benefits of blockchain for auditing and compliance and rule making bills. So what is blockchain? So that is what the question arises. So what do you mean by blockchain? Why blockchain is required? See, suppose if I want to transact some money, what I have to do? I have to, this is my bank. So I have to log in, username, password. Then I can send money to my sister or brother. So this is my sister, I'm sending money. So again, my sister want to see the account. So log in, then username, password. So this is centralized server. So this bank has one server. So I have to log into the server from my machine. So I have to log in here, and then I have to enter the values like username, password. Then I have to enter into the centralized server. Then I have to transact the money. And same way my sister has to go to her account, and then she has to see how much money is transferred. So this is what current system. But what is the problem here? So now the hacker is the problem. So what hackers are doing, they are watching everyone. So in the world, there are two kinds of people. So one kind of people, they know they are already hacked. The another kind of people, they don't know they are hacked. So the hackers are very, very aggressive, and they know each and every transaction of everyone. If it is worth to hack, they will definitely hack. So one fine morning, the attack will come. So what happened to me? See, sometime before, I was using Citibank credit card. One fine morning, what happened? One person from London he started purchasing some artifacts. So first he spent around 6,500, then second 7,500. Two transactions, tuck, tuck, within 3 minutes. So I got scared. Then I called Citibank, and then I stopped the, no, I blocked the card. Then I got back this money. After that, I am not at all using credit cards. Done. That is the last for me. That day is the last day I used the credit card. After that, I never used credit card. So here, the point is, the credit card has some CVV number, then some password involved with that. Then one OTP comes always. Whenever some transaction happens, one OTP comes to my mobile. The hacker knows the CVV number, my credit card number, my password, my OTP. All four he knows it. That is why he cracked this. So he can use my credit anywhere in the world. So hackers are very, very aggressive. So this centralized bank always a risk. So if hackers know the details like login, username, password, they can take the money just like that. So now blockchain is going to give the solution. How blockchain is going to give the solution? Now instead of centralized bank, I'm going to use peer-to-peer networks. So the peer-to-peer, my ledgers are stored in the peer-to-peer network. So my ledger is here, my ledger is here, my ledger is here. So now what happens? Even hacker attacks one node, he hacks this. But my ledger is here and here. He cannot do anything here because of the blockchain data structure like Merkle tree. Merkle tree is very strong. Nobody can crack. So even one node is cracking. Doesn't matter. My ledger is here also. Here also. He cannot do some transaction. The blockchain will check whether if he send one transaction, this block is valid or not. If the block is not valid, the blockchain will not add the block in the blockchain. So even hacker's effort is waste only. So hacker will not get any benefit. So there is no motivation for the hacker to hack this node because another 1 million pieces this ledger is there. Even one PC is the hacking. Another 1 million pieces the ledger is same ledger is there. So he don't have any motivation to hack this. So that is the advantage of blockchain. Then growth. 2018 and 24, banks begin to see the benefits accorded to the early adopters and combined with regulatory guidance and certainty, the network effect takes hold. So in this, what is the, see here you can observe one thing, there is no centralized server. That means the bank is not there. That means there is no bank in India or world, in the throughout the world. There is no bank at all. Only the peers will communicate with each other. They will transact with each other. They will close the account here only. They don't require one centralized agency to validate their account or validate their transaction. So the bank has come. So that is why banks got scared. So now even government got scared because we can get all the license like motor license or driving license, everything we can get without government support. So even government got scared because of this. So new service providers and models emerge. Deployments go viral across numerous assets classes. New products and services are created, incubant process and services are discarded. So once it is matured, what will happen? Blockchain adoption is considered mainstream and integral to the capital markets of ecosystem. So one is financial systems. So we can change financial system. Next is government organizations, like you are registering your documents like house documents, that will go. Then your RTO will go. So finance banks will go. So wherever the government has full control over the people, everything will go once it is adopted fully. So server base. So it is a centralized server base. Now all users are connected. This is the before case. So after case, what will happen? See, each node is connected to other nodes. You can see here, Each peer is, suppose 1 million peers are there. All 1 million peers are connected with each other. That is called peer-to-peer network. As I explained in my demo, we have three peers like minor 1 and minor 2 and R pi. So like that, you can add n number of nodes. So here you can see this one is centralized. Basically, this guy owns the data and will likely charge you to see it. So here the benefit for bank is for every transaction they will get some money. So they are charging. They will lose that money. That is why they get scared. You have to trust him. So we have to trust this bank or government. So sometime before some bank got corrupted, then what happened? People got scared. My money will come back or not. My deposit will come back or not. So you have to trust the bank. So this is the major disadvantage in this case. Then data can be compromised due to mistakes or to serve the third party purpose. Here, if hacker hacks this, so then everything gone. So all money gone. That is the disadvantage. Whereas if they are distributed, what will happen? So here one node, here one node, here one node. So all there is no third party at all. So then this node can transact with this node can transact with this node can transact. So blockchain keeps all of the data synchronized. So if, for example, if you see the blockchain what we are running, so I will see whether my I can show the blockchain what is running now. 1 minute, just a minute. Okay, my blockchain not running. Okay, anyway, I will start it and show you. What is blockchain? Blockchain is an incorruptible digital ledger of economic transaction that can be programmed to record not just financial transactions, but virtually everything of value. So that means any transaction can be done through blockchain. That is why we are using for IoT. IoT, what we are doing? We are sending some message to switch on the light. We are sending another message to switch off the message. This is a transaction from one place to another place. So this transaction we are sending through blockchain, and then we are adding one blocks for whenever we switching on one light, one block will be added in the blockchain. So that will be approved by the miners. Blockchain solves the problem of manipulation. Now, assume in my IoT, I have light and fan. So I'm using, assume I'm using MQTT protocol. So I'm sending the message here and here. Suppose my hacker is hacking this. What will happen? He can switch on light or fan or the door. He can close the door in such a way I cannot come out of my home. That also may happen. So that is called denial of services. So if my door is operated by IoT device, if it is smart home devices are operated by the MQTT protocol or some centralized server, the problem is when hacker hacks this, so the denial of service attack will happen. So my door I cannot open my door, I cannot come out of my home. This may happen. But when we use the blockchain, so we are ensuring that the hacker cannot penetrate our network. In the West, people say that trust Google, Facebook or their bank, but the rest of the world does not trust organizations and corporations that much like India, Eastern Europe, and Russia. It is not about places where people are really rich. Blockchain's opportunities are the highest in the country that have not reached that level yet. So this example what we are seeing is for IoT, but virtually everything can be done with blockchain. Benefits of blockchain. So disintermediation of and trustless exchange. So here third party we can avoid. The main third party is what we are facing problem with our third party is government rules and regulations, or banks rules and regulations, or RTO. So RTO we cannot just like that go and get some driving license. It's not easy. Bank also So it's charging for every transaction. For government, like the registration office. So registration office, you have to pay a huge money to register a house. Maybe if you want to register a 40 lakhs house, at least you have to spend 4 lakhs to the registration office to register your house. So this is the problem of third parties, because we are trusting the third party. We are not trusting the peers. For example, I am buying from owner. The owner is by owner from owner. The purchaser is buying some product, but he is not believing the owner. He is going to the third party and registering the house in the third party. So third party is charging for heavily here. So this is the problem. So that can be removed by blockchain. Two parties are able to make an exchange without the oversight or intermediation of third party, strongly reducing or even eliminating counterparty risk. So there is no risk in the transaction, because so why it is not risk? For example, 10 nodes are there. See, we have 10 nodes in the blockchain. So suppose one transaction has to happen from one node to another node. So the remaining 51 percentage of peers should approve this transaction. So this is 51 percentage approval is required from remaining miners or remaining nodes. So remaining nodes should approve 51 percentage of nodes should approve this transaction. Then only this blockchain transaction will happen. Suppose one hacker is introducing one block here in the blockchain. Suppose we have block server. So one hacker is introducing one block which is not having the valid data. That time all the miners will reject this transaction. So hacker cannot introduce a block in the blockchain. Users are in the control of all their information and transaction. So users can understand it's a fact block. It is not a real block. Then they will reject that. Then high quality data. Blockchain data is complete, consistent, timely, accurate, and widely available. Then durability, reliability, and longevity. Due to the decentralized networks, blockchain does not have a central point of failure and is better able to withstand malicious attacks. For example, so in the centralized bank, suppose if the centralized bank this data is corrupted, then all users will lose their, because the ledger is in the only one place. So that we don't have the ledger of our account, but bank is having the ledger. So even bank is, if the data is corrupted or if data is hacked, then all the users will lose the ledger. But here in the peer-to-peer network, what will happen? The record is stored in the peers. So every peer is having the another peer's ledger. So everybody's ledger is available in all the nodes. So at any point of time, the data is transparent. So we may not see how much money this guy is having, or this how much money this guy is having, but we don't know. But still, this guy what transaction is doing from this to this or this to this, that will be visible. Due to decentralized networks, blockchain does not have a central point of failure and is better to able to understand malicious attacks. Process integrity. Users can trust that transaction will be executed exactly as the protocol commands, removing the need for trusted third party. So here, the protocol commands means, so we are using the standard smart contract, which is validated by every user. So there is no difference. This guy transferring from this to this, or this guy transferring from this to this. There is no same smart contract is used. So everybody is transparent. The transactions are transparent, and there is nothing to hide here. Challenges. Transaction technology. So resolving challenges such as transaction speed. So here transaction speed is the one concern. For example, when I switch on the light or off, sometimes it takes 5 seconds, sometimes it takes 10 seconds, sometimes it takes 3 seconds. The transaction speed depends on miner speed, how much fastly the miner is resolving. Suppose if I have only two miners are there, suppose if I have four miners, so four miners, what will be the speed? So the professors, there is a task for the professors. Now professors can make the research activity like, so I have two virtual machine. Number of virtual machine is two. So what is the RAM capacity of each one? 4 4 GB. Now, professors can do the research act when who is doing in the blockchain research, they can increase VMs to 3 or 4, and then RAM they can increase to 6 GB or 8 GB. Then they can do the research. How fastly this switching on and switching off is done. The how miners so resolving the speed. This is the research activity. This is the research activity required at the moment. So professors can make the tables like this and then do the research and then analyze the data, then publish the research work. So this is what task required by every professor. The verification process and data limits will be crucial in making blockchain widely applicable. Then uncertain regulatory status. Because modern currencies have always been created and regulated by national governments, blockchain and Bitcoin face hurdle in widespread adoption by pre-existing financial institutions if government regulation status remain uncertain. So government very much hesitating. They don't want to publish any regulatory acts. So because of that, so blockchain deployment is getting delayed. Large energy consumptions. So the Bitcoin blockchain network miners are attempting 450,000 trillion solutions per second in efforts to validate transaction using substantial amount of computer power. For example, in our case, we are using miner 1, miner 2 and RPI. So this has to execute day and night, and they are creating the blocks day and night. They are resolving the issues. They are checking the transaction every day and night. So it consumes a lot of power. So that is the major drawback of this system. How blockchain works? So Alice wants to send money to Ben. Then the first block is created, which is called the Genesis block. So then the block is broadcast to every party. So now this block is every party it is transferred. Now the fourth is those in the network approve the transaction and validate. Now miner will mine the work and then they will start approving. If the work is proper, they will approve that transaction. So you have to pay some money for miners to approve this transaction, which is not a big money, but at least some minimum money you have to spend for miners. The block is then added to the chain, which provides a permanent, non-reproducible, and transparent record of the transaction. So now this block is valid block, then it is added to the blockchain. So if the block is not valid or miner not approved, then this block will not be added to the blockchain. Then Ben receives the money from allies. Till that time, the money will not be transferred to the allies. Ben. What does a block look like? So we are talking about block. What do you mean by a block? So a block will be added at each day. For every transaction, one block is added. So this block, what it all it contains? The block has some version number. So nonce. Nonce is abbreviation for number only used once. That means which is number added to the hashed or encrypted number block in a blockchain that when rehashed meets the difficulty level restrictions. The nonce is the number that blockchain miners are solving. So this is what miners will solve this. Some scientific problem they will try to solve. So how fast they are solving, they will get the benefit or they will get the profit out of that. So miners will be compete with each other and then they will try to solve this problem so that they will get some money. So whenever some transaction happens, so we are creating the competition between miners so that miners will solve the problem very fastly and then they will this block will be added in the main blockchain. So the previous block is here, then timestamp is here, then this is a Merkle tree. So the data structure. transactions ID list. So all transactions ID list will be there. Then Merkle tree hash will be added here. So here proof of work is the miners will do this work. So we will see this what is proof of work in the later slides. Now you see individual transaction events. So different devices we are communicating. So the blocks are getting added to the blockchain. So new block of transaction includes the security hash of previous block. So blockchain new blocks are added approximately every 10 minutes. This data they are taken from Bitcoin. So you might have heard about Bitcoin. So it's a very costly digital currency. So in our case, we have two miners and one Raspberry Pi. So the transaction happened within 5 seconds to 10 seconds. Sometimes 3 seconds also happening. It depends on the miner's speed. Multiple computer mining servers check the validity of the blocks in the chain. The quickest to check the latest block, the quickest will get the money payment they will get. So when successful blocks are there, the block is added to the blockchain, which is the honest part of the chain. Then if the block is not valid, it will be rejected from the blockchain. So it cannot be added to the blockchain. So this is the Merkle tree. So you can see the top hash. So here we have hash 0, hash 1 and all. Then again it has another hash 0 and hash 1. And then 00 is there. 01, 10, 11 is there. Then the low level data is stored here. L1, L2, L3, L4. So here the data blocks are added. L1, L2, which is hackers cannot crack this structure. This is Merkle tree. Blocks and Merkle tree. So here you can see the block X is there, block X plus 1, block X plus 2, block X plus 3. So here previous hash is the timestamp, random nonce. So that this is a scientific problem. Then root hash of all transactions below. Then all transactions are here, listed here. You can see then the Merkle tree you can see here how the Merkle tree is that looks like. So it has main hash and sub hashes. Then you can see the last layer is the data layer, which a hacker cannot penetrate. Now we have two kind of the mining work. Hello. So one is proof of work and another one is proof of stack. What is proof of work? The probability of mining a block is dependent on how much work is done by the miner. So it depends on miner only. So how much miner he is doing the work. Then payouts become smaller and smaller for Bitcoin miners. There is less incentive to avoid the 51% attack. So here one problem is, suppose you have 5 nodes, so one transaction is happening, then at least 51% the nodes should approve this. Suppose one hacker has 51% of node, then he can attack this transaction. But when the number of nodes is very less or small, this is possible. But when the nodes are increasing to million, it is impossible for any hacker to hack this. Then payouts become smaller and smaller. And payout also for next miner will be very less money. Next miner very less money. Like that, all miner, the first miner will get more money. Less miner, the next subsequent miners may not get money also. So then proof of work systems have powerful mining communities, but tend to become centralized over time. So again, this also tend to have a centralized system. Then proof of stake is another concept where person can mine depending on how many coins they hold. For example, 100 coins are total 100 coins are there. Then who is having 51% of coin, he can win the mining work. But this is impossible. Nobody can have 51% of coin. So the POS system makes any 51% attack. It's very, very expensive. You should have at least 51% of the total economy of the Bitcoin, which is impossible, highly impossible. Then POS systems are more decentralized but must work hard to build communities around their kinds. So where and all can be used? So mainly we are using for IoT, financial transaction, so financial asset management, programmable legal contracts, even lawyers can use, supply chain management mainly used, then automated stock control, auditing, ticketing, Internet of Things, gambling, then reward loyalty incentive system, insurance, chain of custody, asset ownership, workflow management, medical R&D, digital voting. So this is very important. The election can happen through blockchain, which is nobody can nobody can tamper the system, and we cannot claim that this election is invalid. Nobody can claim that. So regulatory reporting, then KYC and AML, then distributed trading, notary services, payments, tax out many places, right? Digital right management, digital identity assurance. So this is smart contract. Smart contract we are going to use. So we can use digital writing, gambling, escrow, then this kind of thing. Then digital currency and fraud detection for e-commerce, global payment, remittance, P2P lending, microfinance, record keeping, the supply chain management, ownership, proof of identity, intellectual property like patent filing, then loyalty program, then derivatives. Here, security services like equity, private markets, then debt, and then crowdfunding, all those things. Now we'll understand what is transaction. Transactions are data structures that encode the transfer of value between participants in the Bitcoin system. Each transaction is a public entry in the Bitcoin blockchain, the global double entry bookkeeping lecture. So the transaction differs from the blockchain system to system. For example, Ethereum, we are sending the sending the transaction, then one block is added. Whereas in the Bitcoin, it is the encoding the transfer of value between participants in the Bitcoin system. What is a block? Blocks are files where data pertaining to the Bitcoin network is permanently recorded. So this record is permanent, so nobody can tamper this. A block records some of or all of the most recent Bitcoin transactions that have not yet entered the prayer blocks. It is like a page of ledger, or it's a ledger basically. So each time a block is completed, it gives way to the next block in the blockchain. A block is thus permanent store of records. It's nothing but a data structure. A block is nothing but a data structure. Once written, cannot be altered or removed. So this is a peer-to-peer network. Peer-to-peer computing or networking is a distributed application architecture that partitions tasks or workloads between peers. So this is nothing but a distributed database, or you can say distributed computation also, because so each node can do something else apart from transaction. For example, in our case, RPi, it is switching on and switching off the light also. So it's a distributed computation also. Whereas here mining work, so it is distributed database. So here distributed database, here distributed computation. So both are combined in the peer-to-peer network. So peers are equally privileged equipment participants in the application network of the nodes. So what is the advantage? It is easier to set up. All nodes are act as server as well as client. Therefore, no need for dedicated servers. So we are removing the centralized server, less expensive, spend less time in configuration and implementation of peer-to-peer network, and no dedicated server required. Any computer on the network can function as both server as well as workstation. What is the disadvantage? The network security has to be applied to each computer. For example, I have virtual machine 1, virtual machine 2, and RPi. So here security has to be ensured so that the machine is not captured, like VM1, VM2, and RPi. you have to ensure the security of VM1, VM2, and RPI. So that is one drawback. Then backup has to be performed on each computer separately. No centralized server is available to manage and control the access of data. So now data you lost in one thing, so you cannot restore that data. So users have to use separate passwords on each computer network. As with most network systems, unsecure and unsigned codes may allow remote access to files on a victim's computer or even compromise the entire network. What is proof of work? An individual can provide the conclusions to reach a consensus. So consensus is very important. So the blockchain should agree, the blockchain nodes should agree with each other. This is the right block. So I am in the right block and I am doing the mining work rightly. I'm adding new block rightly. So all consensus required for each step. An individual also known as a miner. So in our case, we have miner 1 and miner 2. One Raspberry Pi is just a node. It is not doing the mining work. But here mining work is done. Mining work is done. So calculates the hash of his block header and checks whether the conclusion is correct or not. If the conclusion is wrong, then the miner modifies the nonce and they train again. So the nonce it is changing and trying again. Proof of work is not only used by the Bitcoin blockchain, also used by Ethereum also and many other blockchains. So in our exercise, we are using Ethereum. We are not using Bitcoin. Proof of stack. Mining is done by the stakeholder who is selected by the network based on their stack. There is no reward for the block miner in the POS system. So this is a miner is a stakeholder here. So who is holding some coins? Miners get the transaction fees instead. So cryptocurrencies like Peercoin, Blockcoin, Navcoin use the POS system. So private, public, and consortium blockchains. A public blockchain is most appropriate when a network needs to be decentralized. It is also great if full transparency of the ledger or individual anonymity are desired benefits. Costs are higher and speeds are slower than on a private chain, but still faster and less expensive than the accounting systems and methods used today. So let us start some exercise also in between. So uh, the slides also we have to complete and exercises also we have to complete. Let us take a balance. So we'll do uh, the slides also as well as we'll see the exercise also. Let me start with one exercise. I'll show you how to. The only theory also sometime we will not catch up. So we'll see some exercise also. For example, I will try to do so. So here in this case, so I downloaded the Ethereum. Now I have created one account also. So now we'll try to run one the blockchain and I will see how it is running. So here you can see this uh, if you want to install for Windows, so you can go to the Ethereum downloads. So this is the link where you will get the exe. Suppose if you give this link, you can download like this. See 43 MB. Already I downloaded and installed also. Sometimes this server is a little slow. So now it is open. Okay, anyway, we already downloading. So here you see, then you have to install this. When you install, you will get in the, you can specify the path also. For example, in my case, so you can see here the, in this part, we have installed the Geth. Geth is installed here. Geth means this is the Ethereum software. So I will open the folder also. So C program files Geth. Once you install in the C program files, under that Geth you will get the installation folder. So here you can generate your custom Genesis JSON file. Let me open and show you. So this is the custom Genesis, uh, the JSON file. This is the Genesis block, first block. So you can see here, your chain ID will be given. Then Homestead block is 0. EIP 150 block, then 150 hash block. Then the difficulty level is given as 400. Gas limit is given as 21 and 1, 2, 3, 4, 5. So 2100 lakhs. Then allocation is, so this is the first address what I'm going to allocate. The balance is initially I'm loading with 3 lakh. So here you can see, whenever I execute this, one account, new account, for example, when I execute this, get hyphen data directory. My data directory is Ethereum private 2, where tutorial chain is there. And new account I'm opening. When I open the new account, so it will ask us to enter a passphrase. So for this tutorial, I'm keeping password as blockchain. So again, blockchain. Now you can see one new account is open in this blockchain. So now what I will do next step, this Genesis block I have to create, this account I have to add. So then I have to create the blockchain, the whatever. So here you can see, so already my Genesis block is created. Anyway, I will show you. For example, not this one. So to create the Genesis block, the next step is this. See here, I have to configure this JSON file. Once the JSON file is configured, I will go and create the custom Genesis JSON file, where using this I will create one new Genesis block. Already my Genesis block is created, so it may throw some error. Successfully wrote the Genesis state. Then next step is, what I'll do here, I will just start my blockchain. How I will start the blockchain? So this is the command used for starting my blockchain. So get -hyphen data directory. My data directory is Ethereum private 2, then tutorial chain. So here RPC is the remote port where the CORS domain also I'm defining local host 3000. And RPC port is 8545. RPC API, what and all it will allow is it will allow DB, net, admin, Web3, ETH, personal, SSH, miner. These many protocol it allows. Then there is no discover. That means so uh, it will not the peer will not discover automatically from other peer. So we have to explicitly tell this is the peer. So then verbosity 6, then max peer 2, then network ID is 124, then IPC disabled, then I am going to use the port 30305. So once I enter this, so now my blockchain started. So this is my blockchain running now. So this is the first exercise. The first exercise involves the installing Ethereum and then configure the custom Genesis JSON. Then start one. So first Genesis block, create the Genesis block. After that, start the blockchain. So now new blocks will be added by this blockchain. This is the first exercise. Now we will move to second exercise. Actually, it is a hands-on. Unfortunately, we could not do hands-on. Now, to start the mining work, how I am going to do the mining work? I have to attach here another screen, another window. I will show that. First, I will open a command window with admin permission. So with admin permission, I created one more command window. So let me keep this to the top. Then one more command window I have got here. This is having the admin permission. Now I will go to this path where my get is installed. I will go to get path. Now I will attach. After attaching, see now it is attached. Now you can see mining status ETH dot mining. See it is false. So is it visible for mobile users? You want to increase the font properties. The font size can be increased to 20. Yeah. Is it visible now? Mobile users. Hello, type in the chat box if it is visible or you want to increase the font. You can type in the chat box. So now next step is, so now I can start the miner work, miner now. Miner I can start. Mining work I can start. Miner.start is the command. Just I will enter. See now some changes happened here. You can see here. Started ET hash search for new nonsense. New nonsense is, see here. Started ET hash data set. Okay, here. No answers. So here it started. So Here you can see, now we will see again ETH mining. True. This time you see the mining work is started successfully. Now I will check. See, now I started one blockchain. I can check the balance. So any new blocks are added, whether I got some ether, that I can check now. So ETH, get balance, ETH Coinbase. The main account is Coinbase. The Coinbase is the main account. ETH, get balance. See here, already I got 3 lakhs. So I got. So because I assigned initially the value 3 lakhs, so it is now it is showing that value. You can see here. This is the value it is displaying. Now, block number. We'll check the block number. So which block we are in now? My block number is still 0 only. So my initial value is 3 lakh. Still it is there. So you have to allow some time to run this. And to stop the miner, if you want to stop the miner, you can stop using miner stop. So you can type also miner dot stop. You can stop it. So here aborted is coming. See. Then now you check ETH mining. It is false. So let us start the mining so that we'll get some ether. Okay, it is started now. This is second exercise. I'll move to third exercise. So in the second exercise, what we did, we started the mining successfully. Then we checked the ETH mining status, whether it is true or not. Then we check the balance, ETH get balance, ETH Coinbase using the main account. We checked it is 3 lakh, whatever is as the initial value. Then ETH block number we saw, it is 0 only. So then we'll check one more time whether block number increasing or not. So it's still not increasing. So it's supposed to increase. So we'll see. So we'll wait for some more time. Then we'll move to tutorial 3. In tutorial 3, what we are going to do is download and install Ethereum wallet. The Ethereum wallet, the installer is here. So I will open the installation path. So already my get is the downloaded. You can see here the downloaded path. You can see. So here already I downloaded install, so it is showing 1, and it is around 44 MB. So now Ethereum wallet I want to download. For that, what I have to do? I have to go to that path. See here, Ethereum wallet and MIST data 0.10.0 is there. You can download from this path. You can see here, many files are there. You can download from here. See, installer exe also there. For Linux, it is Linux supported. Linux 64-bit, Win32, Win34, Win64, all are there. You can download from this place. Now what I'm going to do is, I'm going to attach my Ethereum wallet with the blockchain. For that, what I have to do, I have to open one more command window with admin privilege. See, this is one more command window with admin privilege. What I'll do here is I will go to the, once I install the Ethereum wallet, so my installation path is See program files Ethereum wallet. So I'll open that. I'll show you the installation path. See program files Ethereum wallet. So here, when you download, when you install, some space will be there here. Ethereum space wallet will be there. You have to remove the space and put one hyphen here. So remember this point, otherwise it will not work. So here you have Ethereum wallet exe. So what I will do now, I will go to this path, ed. So here I am in this path. I will run this. I will now attach this wallet with my my blockchain, which is running on 8545 port. So it's opening a window. You have to wait for some time. So this is the window it is opening. So I am canceling this. Now, after canceling, there is a window called non launch application is appearing, which I could not move to the second window. So this is what, okay, it is appearing like this. So I'm clicking on launch application. Now, this window is opening. The Ethereum wallet is opening now. It's a mist. I will call this as mist also. So here you can see the main account already having 1069 ethers. So then there is okay. Then one more account we started this time. So that is also showing now. So we'll note down this address also. So here 0 ether. So wallet. So here we are going. So what we are going to do now is click the once launch button is there. So we are going to send this. So I will note down this address from the blockchain. So where we okay. So here ETH. This account number we will note down. This account number will note down. Control C then. Yeah, I copied. What I'll do, I'll go back, send I'll go. From main account, this secondary account will send some ether. Maybe 10 ether will send. So more options. So data I can enter. See here, this is the transaction fee 00021. If you don't want to pay this much money, you can reduce also. But better if you want a fast transaction, you can increase also. So now you have to add this transaction fee also. Then you are sending the value. Send this. So now this window is opening. Send window. Here you can see estimated fee consumption 0.0004 to ether 21,000 gas. Gas is another the unit which will be used for transacting from one place to another place. Then so here gas price is 0.002 ether per million gas. So here you have to enter the whatever I'm using blockchain. To enter the password. In the real scenario, don't disclose your password. Then transaction. Insufficient funds for gas price plus value. See here you need 121,000 gas. Provide maximum fee. So 10 ether I try to send, but there is no fund available. What I'll do, I will go back. I'll reduce to 1 ether. Then now I'll send. So here enter the password. Blockchain. So again, fund is not sufficient. Okay, we'll reduce still 0.05. Then sending. Suppose send it. Your account number it. I'll add different account number. Then here one. Then send it. Maximum fee is this much. So blockchain. So again insufficient fund is coming. I'll check this. So the transaction still has some issue. So if we see here, some previous transactions also there. Maybe that creates some problem. We'll check. I'll check and tomorrow morning I'll tell you. We'll move to next exercise. I will close this. So in this case, what we are going to do is we are going to use Remix Ethereum. Remix is used for developing the smart contracts. So we'll see one smart contract now, how to develop and deploy. The Remix system is used for developing the smart contract and deployment. So here we are going to create one new Solidity program called Hello World. Then we are going to compile and then we are going to deploy. So once we deploy, we can execute the functions inside the smart contract. So opening. So already I have the Hello World. So I tried yesterday, so it is there. This is a hello world. So here the solidity version is 0.4.0. Hello world has a string called public greet is there. So it's a public basically. So it's object oriented program. So I am assuming you know the public private keywords and all. So greet is the string which is having hello world. Then there is one more public address type is there, that is issuer. So now this is the constructor. The issuer is assigning to the whatever message sending. It is the issuer is assigned to that. Then get greeting. So get greeting will return the greet value. Set greeting will set the greet value. So that's it. Very simple.
Excuse
So
me,
what
sir.
we'll do here, we'll go
Excuse me, sir.
to
Anbunatham, sir.
yes.
Sir, I think Vijay Kumar participant has raised the hand, sir. I think he has some query.
Some queries there because I not seen the chat box.
Yes, sir. That is why I am giving instruction.
I'm opening this tutorial and then I'm running. So one window
Okay.
I'm using for opening the tutorial. Another
Okay.
window I'm showing this. So I missed to see the chat box.
Okay, sir. Vijay Kumar, sir, has raised his hand, sir.
Sir, if you can kindly increase the font size, please. Oh, here, okay. Okay.
That person is different, sir, but Vijay Kumar still raising his hand.
Yeah, yes.
Sir, Vijay Kumar, sir.
Sir, a little more will be fine. Thank you so much, sir.
Yeah, yes. But chat box that question is not appearing. Only Sankar Surya Sanwal is appearing.
That
That
only
is
appearing, sir, but Vijay Kumar, sir, I think he's not.
yeah. What is the question? Can you try to retype, madam? The chat box. Can you retype one more time?
Okay, sir, let it be. I will catch him and will give back, sir.
Okay. So if you can retype, then I'll answer. Because it's not appearing for me. Only Sura Sanyal question is appearing. Sir, if you can kindly increase the
No, sir.
font size,
Sir,
please.
I actually requested you to increase the font size. Thank you so
Yeah,
much,
that
sir.
I
Thank you
increased.
for doing that. Thank you, sir.
Yeah, okay, sir. Okay. So then, see here the okay. This is the file. Then this one is a compiler basically. So compiler, we are compile hello world. See it is compiling. Then the next step is once you compile, then under deploy and run. So deploy and run, we'll see where it is. So here, this is the environment, JavaScript virtual machine from the default account for the gas limit with the gas limit. Then I'm entering the value like 0. Then hello world. This deploy by press. What will happen? So now it is appearing here. So you can see here. So set greeting string new string or first we'll see the get greeting. So here string hello world we are getting. So greet what is the value? That also hello world. Now suppose set greeting I'm using instead of hello world I'll put hi. So here I am setting this value. Now again I'll go back. I'll check the get greeting. You can see this time it is high. Greet also I'll check what is the value. You can see the high. So this is a way you can write smart contract, compile it, deploy it, and check the functions, debug the functions. This is the way you can do the whatever no the smart contract. This is the fourth exercise. So now what is the next exercise? We'll go to next exercise, fifth exercise. So here what we are doing is We are downloading the Ethereum, then new account, then project folder, multi-node and everything. Then first node we are starting, then setup and so it's a multi-node basically. How multi-node can be peer-to-peer and all we can connect. Maybe this one is a little big exercise. What I will do, morning I will do this. Before that, I will see any other small exercises there. I'll check. We have another 6 minutes. If you have any question, we'll discuss. So one more small demo I can show within 5 minutes. Even 1 or 2 minutes extra also we can finish it. So first command window with admin privilege I will open. I will open a first command window with admin privilege. So this is the first command window. Then I'll open second command window with admin privilege. So two command windows. The first one, what I'll do, I'll move to this particular path D. In D, I'll go to this part. Then I'll start Ganus CLI. That is one of the, the simulation of blockchain. Okay, what is the error is giving? So error listening address port, address already in use. So what we'll do, we already started on blockchain here. I'll stop this. Control C. Okay, stop. Now I'll try one more time. Yeah, this time it Ganas CLI open. It is simulating the blockchain. It is not actual blockchain, but it's simulating the blockchain. So here it is listening to localhost at the port 8545. So this is the first step. Second step is we'll go to this address in the second window D. So this is the path. So here we have one Python application. I will explain the Python application later, maybe sometime later. So now I'm running the Python. So it's supposed to open Raspberry Pi uh, emulator because actual Raspberry Pi it is not using. It's the emulator of Raspberry Pi does open. We'll see. It opened one GPIO emulator here. You can see here, it check the status actually. What I'll do, the next step is I'll open the Chrome browser. So before that, I would check IP config of my machine. What is my IP? I need the IP now. I'll just open and so. So here IP config I'll check. IP config. You see here the IP of my PC is 192.168.0.104. I'll copy this. Once I copy, I'll open a Chrome browser. I'll open a Chrome browser. Then I'll type this IP address. Now you can see the front end is opening. Now I'll try to control this port, whatever ports are there. For an GPIO 14, I will try to off. And on. 1 minute, just a minute. There is one more window here in the other screen. Okay. So here you see GPIO 14 switched on means the color is changing. See GPIO 14 I'm off. I'm switching off. It is switching off here. Back end something happening. That also will see. We'll keep this side. So GPIO 14 switch off, switch on will do. See the color is changing. You can see here. Then a switch off I'll do. This is simulation of IoT system. So we can simulate the blockchain with the GANAS CLI. Then I'm using one Python application to control one emulated Raspberry Pi. All Raspberry Pi ports I'm controlling from one application. Okay, then today whatever tutorials we want to run, we finish that. So before concluding this session, any questions are there? I'll check. Then next one is tomorrow what we are going to do. Tomorrow with the real Raspberry Pi, we are going to design the application. What is Geth? Geth is Ethereum application. You can download and install. Then can you please share the exercise? Yeah, I'm ready to share. How to share? Okay, maybe I will add it in the.
Excuse me, sir.
Yeah.
Sir, you may share with us. We will send through WhatsApp group, sir.
Okay, I will send to you, madam. You
Yes,
share.
sir.
Okay.
Okay, sir.
Then the slide we are keeping pending, so that will finish tomorrow. Then we'll start with real Raspberry Pi and miners. How two miners can be created? We can do the peer-to-peer, the admin.peer like peer-to-peer connection. Then in real Raspberry Pi, how to program? That also we'll see. How to control the light and all, that we'll see. So remaining part of the tutorial we will finish tomorrow with real device. Thank you very much. Bye bye. Bye.
So thank you for your wonderful session, sir. We really grateful to have you as a resource person in this session, and
Yes.
we would like to have you tomorrow morning also. And really, we are missing you in offline, sir, because it is really more hands-on.
Yeah, yes,
Uh,
ma'am. Yeah.
yes,
That
sir.
is the main concern. Maybe we'll plan later. I need
Yes,
at
sir.
least 2 days program to hands-on, and
Okay.
people should come with the Raspberry Pi. Then I can tell them how to blockchain and IoT we can combine, and then we can make applications. The next
Definitely,
step
I
is
will make.
also
Okay.
we are planning to do the AI. Also, we are going to include this in this application. So I already started. If somebody want to join with me, you can send the WhatsApp message in my number. Then I will include them also for the future projects. Thank you.
Okay, sir. Thank you, sir. Thank you.
Bye.
And dear participants, we had posted the attendance link in chat box. You may submit your attendance and after that you may leave the meeting. Thank you.